Hello everyone, I'm Dr. Emilia Bertolo and I'm a principal lecturer in chemistry at Canterbury Christ Church University in the section of Natural and Applied Sciences. This is another set of videos dedicated to organic chemistry, and I'm going to be focusing on functional groups that contain nitrogen and oxygen. We're going to be looking at some of the key characteristics of these groups. We're going to be looking at how to name them, and also some of the typical properties with the spectrum compounds that contain those functional groups. As usual, I've got the material in shorter videos, hopefully making it easier to follow. And if you have any questions, just drop me an email and we can organize a tutorial. So I showed you this slide in a set of previous videos. And in those videos, I focused on the top row. So compounds made specifically of carbon and hydrogen, alkanes, alkenes, and alkynes, halocarbons, which are when you have the odd, at least one halogen in the structure, and aromatic compounds. We looked at a compound called benzene, which is the basis of aromatic compounds. In this set of videos, I'm going to focus on the rest of the functional groups, the ones that contain oxygen, so alcohols and ethers, aldehydes and ketones, carboxylic acid, the carboxyl group, and esters, and functional groups containing nitrogen. And those, the key functional groups containing nitrogen are amines and amides. Alcohols. The functional group of the alcohol family is the OH group, and this is what we call hydroxyl group. So when you talk about the functional group, you call it hydroxyl. When you talk about the family of compounds that contain that hydroxyl group, we talk about alcohols. They are among the most polar organic compounds you can have, so they can be good solvents of other polar compounds. Probably the compounds that are more polar than alcohols, the most polar ones would be carboxylic acid, but alcohols are close second. Like water, alcohols can form a hydrogen bond. And as a reminder, hydrogen bond is the intermolecular interaction that you have between two molecules when you have a hydrogen attached to an oxygen or a nitrogen or the fluorine atom, so very electronegative atoms, and that hydrogen interacts with another oxygen, nitrogen or fluorine, from another molecule, and those are quite strong molecular interactions. And because you have a hydrogen attached to an oxygen in alcohols, they do form hydrogen bonds. The smaller ones, up to maybe 6-7 carbon atoms, are soluble in water, but when the carbon chain gets too large, they become insoluble, like for example octanol and above. How do you call them? Well, because they're an alcohol, the ending of the name would be OL, all, and you name the number of carbon atoms you've got. So if you have one carbon atom, you have a methanol, 2 carbon atoms, ethanol, propanol, butanol, pentanol, etc. And sometimes when the OH is in a particular carbon, like if it's at the end or at the beginning, if in one of the end carbons or one of the carbons at the end of the chains, then you don't have to number it. But sometimes when it's in the middle of the structure, you will need to tell your reader, like for example, in the last example, this is propanol because it has 3 carbon atoms and 1 alcohol, but the alcohol, the hydroxyl group, is not at the end of the chain. It's actually specifically in carbon 2. Alcohols. You might have heard about primary, secondary alcohols, tertiary alcohols. The same with other compounds. You might have heard about primary, secondary, tertiary organic compounds or carbons. That refers to what we call the degree of alkyl substitution. So how many carbons you have attached to that carbon you're looking at. So for example, here you've got this carbon here that has one, you have this R here, so imagine this is a carbon. It has 1 carbon attached to it and the rest are hydrogens, or in this case 2 hydrogens and an alcohol. You call that a primary alcohol. It's substituted by only 1 carbon. The next one would be a secondary alcohol. It's in this case an alcohol is a carbon with an OH and that has 2 carbons attached to them. And finally, you can have a tertiary alcohol. And this is a tertiary carbon. It's a carbon that is surrounded everywhere, doesn't have any hydrogens, it's surrounded everywhere by carbons. I'm just giving you a couple of common names. For example, propane 1,2,3 triol is what we normally call a glycerol. You might have also heard about it's an antifreezer, ethylene glycol, or you might have heard about phenol, which is the name that we give to the alcohol of benzene.